Hello and welcome back. If you have been following the channel for a long while, you know that we are involved in the maintenance of an ancient IBM 1401 mainframe at the nearby Computer History Museum in Mountain View, California. Yes, that would be right next to Google's headquarters. This computer underwent a massive multi-year restoration, and it now provides bi-weekly demos for the delight of our visitors, some young enough to be unaware of what computers looked like before the age of iPhones, and some old enough to remember programming it. One of the most prominent features of this late 1950s computer is the row of magnificent tape drives. They are wonders of electromechanical wizardry, and we have had quite an epic repair done in 2016, one of my first videos about this system. Well, guess what? The tapes started acting up again when we turned them back on after a long COVID hiatus. In one system, we have 3 out of 4 down. The one I'll be taking care of has a problem that you'd think would only happen in a car. It looks like it has a bad clutch, which is pretty bad news because it's an engine out repair. The clutches in question are magnetic, and there are 6 of them in the machine. There are 3 of them at the back of each reel shaft. These clutches are responsible for controlling the hypnotic reel movement. See, the start-stop tape drives access the tapes record by record, which requires huge acceleration and deceleration forces. But in the 1950s, they did not have the power electronics capable of directly controlling large DC motors. So instead, they went for an electromechanical solution. 2 huge AC motors drive clutches continuously, one for the forward and one for the reverse direction. When a reel needs to be moved, an electromagnet in the clutch corresponding to the correct direction is activated. It is both very fast, very powerful, but also very progressive. The inductance of the magnet ensures that there is a nice ramp in torque and reel acceleration. It does everything you do today with an advanced PWM servo control system, but without any electronics. Genius, if you ask me. It's unloading. Here you go. But when they don't work properly, things go pretty bad. Ours would break the tape.
It went into the tape from. Yeah. No? Yeah. Did it break? No, wait. Oh, that's real big more. Yeah.
At this point, we suspected the brake clutch was the culprit. It is the clutch closest to the front panel with the crown gear. It is only used during loading and unloading to move the reel really slowly. You see it turning right there in the front? And that's what moves the 2 reels slowly in counter-rotating motion. It is only used to lower the tape in the vacuum columns when loading, like you see here, after which the faster forward and reverse clutches take over. Somehow, it did not always release. And sure enough, that's the hardest clutch to get to. You have to remove the entire shaft. It takes the better part of the day. It starts with temporarily supporting the shafts with wire, but I use modern zip ties instead. We'll see the inverse process better when I put it back together later. And since it's an old machine, everything is somewhat stuck together. This is actually the second time I did this, so this is much easier now. Still gave me a hard time though. The first time around, we could not find anything wrong with the clutch when it was on the bench, so I am a bit puzzled why it's still locking up randomly. Still does not want to come out, so I needed to use the rubber hammer for a little persuasion.
Okay. There's a baby. He's born. Yeah, and it's stuck. I can feel it. The clutch is stuck. This is very...
I got it out eventually. The clutch fell stuck this time, which is actually good news. Looks like we caught it in the act this time. So the problem here, so this is fine, clutch 3. clutch free, that's the forward and backward. And that's the loading clutch. And it's not free. Turns the shaft with it. And it should be free, like the other ones. So that's our problem. At the last time when we took it, this wouldn't even, it was free. So the intermittent fault is more permanent, which is good. And of course, to get that one out, you have to get this and this. That's the last one. It's just beautiful mechanics. Bearing, new bearing actually. That's the rear, let me mark it rear. And then that should, now it slips out because I cleaned it last time. And you see the key, got to remove the key. Maybe.
Oh, what's the name of that key?
It's called a Woodruff key. Last time it took me an entire day to disassemble the shaft, but now it's super clean, so it should be way easier.
Wait.
Did you have this much trouble before getting it apart?
Yeah,
Oh.
even more because it was stuck. So this is, but I thought this, oh maybe I need to get that one from first. I need to get this one first. Yes. Thanks, Hammer. Tolerances are super tight, so even a slight imperfection like one I found on the shaft here will cause things to stick very hard. The card, it started to move again, so now it's free.
Mm-hmm.
So sometimes it's free, sometimes it's not free, and we could not. So that's where I was last time, saying, okay, fine, now it's perfectly free.
Mm-hmm.
Then we put it back in the machine and it hangs again. So what is it? So we're back to where we were before. Grand opening of the magnetic clutch that doesn't behave. And there should be magnetic powder in there. Ooh. I have to find my way in. Come on. There we go. It's coming.
It looks fairly,
Yeah, it's that stuff. That shouldn't be outside, I guess.
Mm-hmm.
That's binding.
Leak through.
It's binding with this. So I guess if we clean this, is that supposed to be is that supposed to be felt? It is felt, so maybe that's the problem. Maybe that's that felt thing that has gotten bad. And because this is could be better. Okay. So yeah, yeah, that's another seal. So
let me give it a try.
that might be some of our problems. This is full of powder that went everywhere. So inside the clutch there is this black powder. That's perfectly normal. That's the magnetic powder that's activated by the magnet and makes the clutch work. Right away I have some doubts on the seals, but I would only find the true cause of the problem much later. These were actually good seals, but the wrong ones. Long story short, but it looks like the bearing got damaged by the powder and needed to be taken out. Luckily, we had a big press on hand. Here I am pressing the clutch bearing out using smaller bearings as interposers to transfer the pressure to the bearing I am trying to take out.
Plunk. Oh my goodness.
Bearings out. So that's the original bearing. Oh yeah. Oh! So here are the forward and backwards clutches, and they are all fine. And here's the one that's causing us trouble, and I already cleaned it up. And here's the inside of the clutch. So normally it's full of this black metallic powder, which goes everywhere. And the way they work, that's the rotating part of the clutch, and the powder is all in between, and then through these rings, through the brushes, you induce a current in, there must be a bobbin somewhere, an electromagnet, and that seizes the powder and the clutch becomes one solid element. And so what has happened is that there is a felt seal. There's one on the top, and there's supposed to be another felt underneath to protect the bearing, and it wasn't there. And then the powder attacked the bearing. Yeah, you can see it pretty well here. So the bearing is shot. I think the problem was that there was a seal missing. There should have been a seal in here, and there was nothing. And it just chewed up the bearing. And there should have been this in there. And again, as I realized later, it's not that the felt wasn't there, it's that it was the wrong size felt on both sides to make things worse. And it's a special bearing. It's not a regular size, but the restorers found out that if you take an old SKF bearing of half the size and you put two of them, you should be okay. So off to eBay we go, and I got the same old SKF bearing, and hopefully we'll replace that, put a new felt seal, put some new powder back, and we should be okay. SKF bearing. 2 new bearings equates almost to one old bearing. And what made the fall really difficult to diagnose is that this bearing is fine as long as the coil is not energized. So when we took it out for the first time out of the machine, it couldn't find any fault. But as soon as you put it back in and the coil is energized, it also seizes the bearing at the same time, and so it makes for a nice intermittent fault. All right, so we'll press those back in and put the whole thing back together. Okay, using a smaller bearing to press them in. Okay, first one is in. Second one is in. The circlip. So that's the most annoying step. Oh! And now the question is, how much magnetic powder should we put? And for that, I have the notes of the previous restorers. I think this one is from a guy named Alan, and he must be my twin because he took super good notes, and he made this drawing of the whole shaft and the clutches, and guess I made the same drawing. And he says spec for the powder in the clutch is 22 grams, but then I read 2 pages later or 3 pages later that the IBM powder, they had 22 grams, but then they to reproduce the same torque they had to add 29 grams of the Placid powder, which is the commercial powder that we have here. So actually I wrote my scale somewhere. Okay, that's right. So before I fill it, I have to put the felt back, and that's when I progressively come to realize that the wrong felt had been used. It's quite deviant. There are several versions of the clutch that use different felts. Here I put the right thick one in, then trying to replicate what I saw when I opened the clutch, I had a thinner, wider one on top. But that is not correct, it doesn't belong there. So I then correctly remove it. Then on the back I tried the thin one they had. That's not correct either, but that's much less obvious, and I will only realize that later. So hang on that thought for a moment and let's fill the clutch. Okay, so we got pretty much everything in there, and when it rotates, of course, the powder goes to the side, so it's not super critical. So now I can reassemble the whole thing, and it does not feel right, and that's when I realized that I need to look into more details at that felt situation. So I tried to get a good drawing of the clutch showing the felts. And the first one I found has the thick felt at the bottom, just like I did correctly, and a thin one at the top, just like I did, but if you look closely, you can tell that the top plate of my clutch differs from what is in this drawing. And that's when I realized that there must have been several revisions of that clutch. And indeed, I later located a drawing which shows a thick felt at the top, which would match my plate design. So phew, I finally got what I believe is a correct felt combination which fit perfectly into the provided cavities and let the clutch slide snugly without any powder leaking. Now is the time to do a quick test of the clutch. So this is set for 270 milliamps, which should be the correct amperage, so it's free right now. And go for it, Tom.
Doesn't
turn it.
Doesn't turn. Turns.
It clutches. Alright. Oh man, reassembling those is a misery. There we go. Yep. You have those two half moon thingies. They go like this, they go like that. And then they get squeezed. There you go. Like this. There you go. No, it pushed the key out. So it's already hard like this. You can imagine what it was when it was all goopy. There you go. Okay, I have something that's not quite right because I have too much slack in there. So I need to tap this one in. And take the slack. It did. Alright. So now comes the reassembly procedure. First I put the shaft back in place, held by zip ties. Then I put the belts over it. Then slide the back casting in place, which I had put on temporary long bolts. Get it to fit over the rear bearings. Now the ties can be removed. Repin the front hub. Adjust the bearing play with the nut at the back. Lock the nut by bending the lock washer paddle. Reconnect the real load motor, which is the one that moves our infamous brake clutches. Reconnect the high-speed rewind motor. Alright. Okay, now I have to put the brushes back. They are what makes the contact with the slip rings over here. And it's a delicate operation because the brushes want to be compressed before they go in. So that I've made those very special tools cut out in punch cards. One goes in here, there. Can you hand me that screw over there? And there we do. Done. Yes. It's super hard to see, but there you contact the clutch right here. Then the last step is to put that in. It has springs in it. The springs do push on those compression rings here, and then you can adjust the tension. See if that works. Yeah.
Perfect. Yep. Loose like this and strong like that.
And finally reposition and tension the belts.
Here, one motor moves in one direction and the other motor moves in the other direction. Okay, so now I have to tighten those the right way until the belt is tensioned correctly. I put the power on. I have not put the data connectors yet. Power on. There you go. Does the clutch work? It does. Unclutched. Clutch. I have a little button here to unclutch it. I lose the tape, so that's and very strong, so that's good news. Well, rewind. Did it. Alright, so let's reconnect it to the data cable and see if that works. So those big guys are always a load of fun. Over there, and over here we have the secret panel. Alright, it's addressed by the controller. It sees it at load point, that's correct. And if I start to, so I mean go forward over here, if I do start, oh, there you go. How do I stop it? I do reset and stop and rewind it. Yep, I think it's repaired. Okay, and let's go unload. Oh, reset, unload. Okay. So now we have to put the door back. Go. Okay, unload. Yes. All right. Repaired.
And this, my friends, is how you do a clutch job on a magnetic tape drive. From the time when mechanical engineers ruled the earth, and you'd better know how to use a wrench if you wanted to repair your electronics.